Hello everybody, welcome once again. Here is Rajesh our YouTube channels. Now today's I will teach you the physics. In physics we are studying, as we know that we are studying the work and the energy. Now today also we will study the work energy law of conservation of mass. In work and energy we will study the law of conservation of mass, law of conservation of mass. Sorry, so I'm not watching here. No problems. So law of conservation of mass, law of conservation of mass. We are going to study law of conservation. Also, what is definition? So in the energy neither can be created nor be absorbed. It can or destroy. It can be changed one form to transform one form to another form. So this is the law of conservation of mass. One by one, so we will write here. So energy. It states that energy can neither be created nor be created neither be created nor be destroyed. It can not destroy. It can only be transformed. It can only be transformed. Okay, transform from one form to one form to another. Then the total energy to be before and after the transformation. Then the total energy before and after the transformations always remain constant. Here is a constants. Now we will study the constants. Means that energy neither be created nor be destroyed, can be transformed one form to another forms. And the final in total energy after the transformation or before transformations always be constants, means that always be as it is. Okay, so here we have studied about this. Now conservation of energy during the free fall. Conservation of energy during the free fall. Okay, here is the heading: conservation of energy during the free fall. Suppose that any object is here. B is any object that was at point B, and it's a free fall from B to A, and then after from A to C, and distance of this from B to C is H. Okay, and okay, and here is the A to B distance is here. Okay, then here is the distance h. So point B and A. So we will consider that. So let's have concept during the free falls. During the free falls. During the free falls, a body considered a mass. A body considered mass is equal to, mass is m. Okay, so at the times of total energy at as at point B, at point B. Okay, m at point B. Okay, so suppose that it's a heights. The heights arc from A to B is h. From the heights, from height from B to A is h, and height from B to A is h. Here is, then suppose that then at point B, what will be at point B? At point B, the from length is suppose that at point B, the at start of free fall of an object, potential energy will always be mgh equal to m into g into h, and the kinetic energy will always be ke, will always be 0, because at that times of that kinetic energy it is stable, and stable forms at that times before the free fall is happening, and after starting its kinetic energy will 0, because kinetic energy will 0 at the times of, so total is equal to, so the total energy is always be Pe plus Ke. Pe plus Ke is equal to always be, because it's a 0, so it will mgx. Okay, mgx, mg and the x is distance here, so mgx is equal to mgh. Got it? Mgs at point B. So total energy will always be at point A. Now at point A, at point A, what will happen? At point A, at free fall conditions, what will happen? Kinetic energy will Ke transforms potential energy transform into kinetic energy, and the kinetic energy will always be m into g into s. So mg as half mv square. Kinetic energy will be half m, and potential energy P is equal to m into always m into gh. Gh is here h minus x is equal to, this becomes, okay, at point A it becomes m into ghx. So the weight arts total according to the third law of motions of equation of motions, third law of motions. Here is the v square is equal to u square plus twice gx. Okay, so v square is always be 0, because starting at is equal to 0. So v square is equal to u square plus twice gs. So v square is 0, then v is equal to u square. U square is 0, then v square is equal to 2gx. Okay, v square is equal to 2gx, twice gx. So v square is equal to twice gx. So kinetic energy will always be half m v square is equal to 1 by 2 m into x gx, because gx, because v square is equal to twice gx. So we can write here is always be m into g into x is equal to m g H. Okay, at point that. Now we will consider about this conditions that mg is the total energy. Total energy is always be mg into h minus x. It will be mg into x minus x plus mg x. Okay, is equal to always be, because it's considered as a zero. The value is always be zero, so it will be mg h at point at point C. What will be the potential energy at point C? Is at we note that when the potential energy decreases, PE decreases and KE increases. PE decreases, KE increases. Then what happens? PE decreases, KE increases. Then it will be P is equal to PE considered as a zero. So K is equal to half mv square. KE is equal to half mv square. Got it? So K is substitute these values in. So total energy is always be considered as m into g into h. M into g into h. Why? Because height is always be what? Height is equal to always be m1 by v. Height is equal to 1 by 2 m and h minus x. This will be the h minus x. H minus x discharge, because as we know that v square is equal to twice gx. So total energy will always be that. So thank you very much for coming out. Sir, once again I am giving you my warm welcomes that you have come here and try to understand the potential law of conservation of mass and its positions at the times of free fall from the, so when the object is as A positions, and when the object B positions, and when the object at B position, A positions, and then after the final at C position before and after the reaching on the grounds at zero. Okay, thank you. Welcome. Don't forget to subscribe my channel so that you cannot miss the video. Okay, bye bye.